The simplest I/O core that you probably can think of is a general purpose input or a general purpose output. So in this here, I'll show you the general purpose output. So the purpose of a general purpose output is just to give the processor a way to send data to the outside world in a very, very simple way. And in this here, this is basically the core that we have. And this general just GPO is connected to the LED. So whatever the processor writes into it, it actually gets displayed on the LEDs. So the first step in constructing and connecting and everything, the steps that we actually covered in a previous video is actually, let's design the custom digital circuit. And the custom digital circuit is really a register. That's what the general purpose output is. It's just a register that contains a bunch of bits. There's nothing to it. And taking a look at this code, we're going to have to see that there's actually just a register. So if you take a look at that, that's basically what it is. It's a buffer register, and you can read and figure out the code on your own. It's pretty simple. It's just a register with an asynchronous reset. Okay, next what we need to do is to figure out that this is a register. We need to actually connect it to the whole system. And in order for us to connect it to the whole system, we need to connect it to the MMIO controller. And in order for us to do so, we need to make sure that it has all these signals we specified before. So take a look in here, and you can see in the module input and output, we have the following. Of course, the clock and reset, because it's a register, and actually all of them should probably have it. Well, actually not all of them, but because it's a register, it needs a clock and a reset. Not all of them need it. But maybe you're designing some custom logic that doesn't need a clock, so you don't need it. But anyway, what we have in here is this slot interface. Okay, so in the slot interface, it's exactly the same. We have the chip select, the read, the write, the address, just 5 bits, and then the read and write address, and so forth. And some of them are, well, the read address is an output, and that's it. And if you think about it, this is a general purpose output, so chances are we do not need the output in here because we're not going to be reading anything from an output. Okay, but we have to specify because this is what the MMIO controller is actually expecting. In order for you to connect it to the system, it needs all of these signals. Anything you design needs these signals. Then you have some sort of an external ports. Not every I/O core you have can or should have I/O to the external world. In our case in here, we have to have one because we're connecting it to the LEDs. So we're going to connect these out to the LEDs. So another example we'll see later, for example, the timer just does not need anything to the external world. So we don't have any of these. We just have the interface, the actual interface, and that's it. Okay, so we take a look at the code, and in the code, again, you will have to know that anytime you see some sort of writing, that means there's decoding. Anything that is reading, that means it's multiplexing. And these are what's happening in here. Because we only have an output in here, and the output is just writing, that means there's only decoding. There should be no multiplexing whatsoever. And there might be neither, because we might not have any addresses or whatnot. Because here, the second step after you design the I/O core, and you need to actually connect it and whatnot, you need to determine the register map before I actually derive all this like circuit that we have. And I didn't talk about the register map because frankly speaking, I have this particular core has access to 32 registers, but it doesn't need 32 registers. It just need one register, and that's about it because it's just a register anyway. So its map is just a register that you can actually just write into it, and that's about it. So because you only can write into it, so it's decoding logic. So let's take a look at the code for the decoding logic. So decoding logic tells me, okay, I'm defining a new signal called write enable, and the write enable just is write whenever the processor actually specify my address. This is where the chip select. Remember, the chip select comes from the MMIO controller, and it's based on the address for this particular slot in here. So this is slot number 0, 1, and 2. So if the address has that particular number in it, it will be basically selected, and the processor needs to write. So if both of them are true, that means the write is enabled, and of course I'm going to incorporate it in my writing or the code for the register in here. The read data in here, as obvious as it is, it's actually just connected to 0. So the output of this in here has an output that is 0 because the processor is never reading anything from it. And what we have is just basically we're taking the external output as is, we're just basically connecting it to the output. Basically the internal register, we're connecting it. So you might be asking, then what's the purpose of this address? Well, the address was the internal register within the core. The core, again, have a register map that should have basically 32 rows. Each one of them is 32-bit, but we're just using this particular row. We don't have any other row we're using, so there's no need for us to use an address. Anytime we're trying to write into this particular core, we're definitely writing into location 0 and nothing else because I'm not writing anything else. If a core has a little bit more complication, we will start using this address.